Hello, Dr. Jafar. This is Colin Costuge going over uh, my test one and correcting where I made mistakes. The only one I will not be going over is question two, because I'm not sure what I needed to do to get that correct. Now, question one, I completely misread these questions, so I got C wrong completely, but I know I got B right because that one's true. I just didn't fully read what was the questions. So here's my corrections. So with A, it is 2 pi because in this equation, with the limit and all that, the limit is 2 pi because it would be 0 when you put it into y, or t for this instance, it'd be t. So as you can see here, 4 is equals to roughly 1.84, and 2 pi equals 0. It also does the same thing for pi. And for C2, for part B, this is also true because it does not equal 0, which means it is in the confinements of pi, yes, it's also in the confinements of pi and 0, as it's not greater than pi and it does not equal 0. But it also does not, it's not breaking infinity or infinity. It's not breaking the limit. So it's not infinite, so it's in the confines of infinity and negative infinity. For part C, this is the one I completely misread. I thought, oh, this is just quiz 1. So just explain what equilibrium and stable and unstable are. So the stable points are pi, and the unstable points is pi divided by 2 and 2 pi. As you see here, I just used the same equation, the y minus pi over 2 times sine y. So when you put all these numbers up here, you get with negative 1, because we're starting off with 0, would be 2. So that means it's going up. So it's going towards 0. 0 is just 0. And for 1, it's going down because it's negative 0.42, so it's going towards 0. So for 2, I just put that in just to have it, so it's going, which is more than to pi over 2, so it would be going towards pi, since it's less than pi, so it's going towards pi, it's positive, going up. And then 3, which is also up, but it's also less than pi still, so it's these two are redundant. 2 is redundant. So it's going up towards pi. And 4, which is more than pi, is negative, means going down towards pi. So that means pi is stable, and as well as 0 is stable. As well, this repeats. I didn't put that up here, but it repeats for every odd pi. So 3 pi will be stable, while pi 4 pi, will be unstable. So, and I continue. So with 5, it's negative, so that means it's going away from 2 pi because it's less than. And then 6, which is still, or it's just redundant, it's still just barely under 2 pi because 2 pi is roughly like about 6 or something like that. No, 6.2, roughly around there. So it's also negative, so that means it's going down. And for 7, which is definitely above 2 pi, is 3, which means it's going up and away from 2 pi. It's actually kind of funny with this equation. You kind of learn that 3 pi over 2 is semi-stable, as it's going. Wait, no, not semi-stable. Semi-unstable, because it's going down, away, both down. Is it semi-stable or semi-unstable? I'm pretty sure it's semi-unstable, because I think semi-stable is only if both arrows are going up, while semi-unstable is if both arrows are going down. I don't know if that exists. I might be wrong with that. Probably am. But I know that 0 is stable. I know that pi over 2 is unstable. I know pi is stable, and I know 2 pi is unstable because the arrows are going away from 2 pi and pi over 2, and the arrows are going towards 0 and going towards pi, meaning that they're stable. Now D, I believe I got that wrong. Yes, because I chose false. While it's true, that x squared plus y squared equals 9 is an implicit solution of y prime plus x over y equals 0. Doing the math, if you break this down, you get 2x plus 2y, then you divide the 2y over here goes away, then it's just times that by dy dx, which equals 0, then it just becomes the 2x divided by the 2y. The 2's just go away, meaning it's just x over y, and then it's the dy over dx, which then would just be y prime plus x over y equals 0, so it is an implicit solution. So now on to 3. 3, I completely messed up on. I did not read it right. It is a substitution, which looking at it is quite obvious. You got a lot of the same things going on. And with this section here, I'm working towards actually making them all equal a same integer so I can convert it to v. So that's what I did here. So you got all of these now become y over x, y over x, y over x, y over x. So then I can make it substitute v as for the y over x, which then moves on to becoming this equation. So it's 1 plus v minus 1 minus v divided by 1 plus v minus 1 minus v, all square rooted, times dv times dx times x plus v, which, when you do the things for y prime and v prime, that's what you get. And that then equals the same thing, just kind of just simplified down, where the top becomes positive instead of the 1 plus v minus 1 minus v. It just becomes 1 plus v square rooted plus square rooted 1 minus v, and the bottom doesn't change. Then you start working out the problems to get rid of the bottom, the denominator, and this, which then doing that results to 1 plus v plus 1 minus v plus the square root of 1 plus v times 1 minus v plus 1 square root 1 minus v times 1 plus v divided by 2v, which then converts to v plus dv divided by dx times x, which equals 2 plus 2 times square root of 1 minus v squared divided by 2v, which then 2's go away, and you get that v over here on this side, and then the dv divided by dx x equals 1 plus the square root of 1 plus v squared minus v squared divided by v, which then you will integrate. Not like you would flip it and then integrate it. And you'd also integrate the x, which becomes now 1 over x dx, which then gets you negative ln absolute square root 1 minus v squared plus 1 equals ln x plus c, which then, once you put back the y divided by x, equals negative ln absolute square root 1 minus y divided by x squared plus 1 equals ln x plus ln z. And this is the substitution method. Before, I think I said it was the subtraction method. No, that's 5. Here's 3. Yeah, 3. Oh, I didn't actually say any of them. I didn't know. I think I did try to do the separation of values. That's what I tried to do. I tried to separate the values out, which didn't really work in my favor. At least that's what I think I did. Looking at this, I did not. I tried doing the substitution, but I think I got confused. And I think where I'm getting confused and why I'm saying I think this is the separation of values is because this is separation of values. I believe this is separation of values at least. And that's why I'm getting that confused. My bad. But this is the substitution method. And I do try doing that. It just seems I messed up in the getting the v equaling something. That's why I got myself mixed up. I'm pretty sure that's where, yeah, that's just what it looked like. So now on to 5, which I actually did get correct mostly in the test. The correct answer, though, for this is actually not negative x squared sine y minus y 3 e to the x. It's actually x squared sine y plus y to the cubed. Yeah, cubed. X e to the x equals c. It's positive, not negative. I just messed up my signs there. Everything's the same. You just start out by put it, the dx dy. And as you see, I put dx and then dy dx over here. And then finding the m. And then the n. And then the dm dy. And then the dn dx. Which results in an exact solution because dm and dn equal each other when you focus what's the word differentiate, I think, the y's and then differentiate the x's results in the same thing. So then you integrate the m and then the n, and the integration of the n equals 0, while the integration of the m equals the answer, obviously. But on the way to getting to the answer, you would take out certain things. For example, the sine y gets out, and then the e to the x is pulled off and separated, and the y cubed is also pulled out of the integration, which results in sine 2 sine y, because also the 2 gets pulled out of here too. So it'd be the integral would look like 2 sine y integral x dx plus y cubed integral e to the x dx equals c, which then would equal 2 sine y x times x squared divided by 2 plus 4e cubed e to the x, as e to the x equals itself, so nothing changed there. So, and you simplify by getting rid of the x squared. You will get rid of the 2 under the x squared and the 2 times sine y, as they're all being multiplied together. So that means the 2's just go away, resulting in x squared sine y plus y cubed e to the x equals c. And that's my text corrections. Hope you enjoyed the video. Leave a like, as this is going on YouTube, and thank you for the opportunity for the extra credit, Dr. Jafar. And hopefully you had a good weekend.